Okay. Hello everybody, my name is Tornike Karchkadzhe. I'm from Sibelius Academy. I'm sorry to be guy who takes your coffee break, but I will try to do it really fast. So my topic is machine learning in synthesis, and particularly what I did is the really essential, really easy thing, just using machine learning in wave shaping, learning neural networks to understand what is sine waves, square waves, and reproduce them back. So I will just go through this kind of notes for myself, basically. So like digital technologies have really long history of being in audio, like from recording, reproducing, anything. And so sound synthesis are using digital technologies lately, but mostly they are implementations of synthesizers, hardware synthesizer, electronics, but of course there are lots of methods nowadays, like we seen a few minutes ago or yesterday that people start to use computer technologies in a different ways, like the ways that electronics don't give us chance to use. And new, kind of, it's not new, it's like 50 years, more than 50 years that it exists, but kind of nowadays more powerful computers allow us to work with so-called artificial neural networks. And the data-driven approach of neural networks is really unconventional and non-traditional, and it's really different from the existing methods. So brief history of using artificial intelligence. You can see that it's from 59. Some people, Hiller and Isaacson, then Yanis Xenakis was using Markov chains. David Cope is really famous with his lots of books about it, about using artificial, mostly Markov chains. But yeah, and also in 1989, there was first try to use recurrent neural networks for music generation, but mostly before last 2 decades, artificial intelligence methods were aimed to MIDI information analysis. And now in last decades, people start to use neural networks on sample-by-sample basis, which is really interesting, and my interest goes there. So we see that Wavelet was published in 2016, and since both are from Google, and they give us really interesting results. And why this is interesting, particularly for me, is that they kind of merge sound synthesis and composition methods. Like you give it sound samples or composition, it learns, and then it synthesizes and composes in the same time, which is really interesting, and it's a kind of dream of every composer to come from like a really small sample to composition. I'm really kind of fascinated by this fact, and I really think that it's kind of future. So, and yeah, so it is my research question and motivation to do this. Yeah, border of synthesis and composing, and my research question is kind of how far you can go from sample to big forms. And yeah, my final purpose is to make some kind of software, standalone instrument or VST, whatever, which can take in some audio, or I don't know, search in internet, listen, analyze, and then generate it back. So now it's hard problem for me to explain what is a neural network in 5 minutes, but because it's quite complicated thing. But like if I say really simply, it is set of nodes. You can see here, these are nodes, and they are connected to each other. They have connections, and every connection has its own weight. So basically what happens here, every node, like number, this is number from 0 to 1. Every number is calculated by previous layer numbers and weights which are on these connections. And kind of, we can see that there is a formula like this. Like weights to previous node neurons, and then you put this sum in sigmoid function, which is function like this, to keep it from 0 to 1. But yeah, this is kind of theoretical idea, but the practical idea is that it's just empty network. It doesn't know anything in the beginning. It just connected with random numbers, and then you take your inputs, you take your target outputs, and you put in network, and there is a method, back propagation, and you start to tweak these connections, change these connections. And after many long learning process, this network start to understand what you want from it, like what you try to get. So that's how it works. And this method is called this process of tweaking and changing these weights called machine learning. Yeah, I'm sorry if it's not enough explanation, but I think now it's better to go, and if you are interested, you can see there are lots of information on internet about neural networks. So what I'm doing now, and I want to really show you some examples how it works. I'm taking neural network. I'm taking sound files. In my case, it's just sine wave, 3 seconds of sine wave, 1000 hertz. And I cut this sine wave into 1024 samples chunks, and then cut each chunk on the half, and I take 512 as an input layer and 512 as an output layer, and I feed it into neural network and try to teach it how to understand that it's sound wave, and somehow changes weights. Then next time when something similar to sine wave comes here, it outputs continuation of this sine wave. Like if it's these 500, like these 500 samples, it should understand that it's part of sine wave, and okay, we now go like this or like. So it is kind of the idea what I'm trying to do now. Yeah, it's written here, and my aim is to get same sine wave. It's just really easy. It's not magic, just same, nothing really complicated. Because if you go to complicated waves and time changing, then it really becomes complicated and really hard. And so far I haven't gone there, but it's my aim in the future. So this is network. I'm using Python for prototyping. So this is small code which I wrote for this process. And now I'm going to show you the original wave and then generated wave. Okay? So this is original one. Just really standard sine wave with everything. So and then yeah, you see it's learning process is happening. I'm choosing, just to show you more details about learning process, it is, the neural network is 500 input layer and 500 output layer, and I have like hidden layers, 30 neurons in hidden layer, and then how I do learning processes here. I do 100 epochs. They call it epochs. So and I check every time I choose 10 data units and feed them into network, and I do it 100 times. So, and the result output sine wave, it looks like this. Not that nice, little bit noisy, but still sine wave. It is just starting. Am I using really simple neural network? Is just 500 inputs, 500 outputs. But the fact that it gives me sine wave, it's really promising, and it means that I can go farther with this and generate whatever. So now I'm going to show you the same thing on square wave, and then we can have questions and coffee. Okay. So this is square wave. I just want to sort of show you the original one, and then continue. Learning epochs. Here we are. Yes.
Much improved.
Little bit ugly. I'm sorry.
There's an advantage in not learning things too well.
Yes, of course, and also, yeah, as Andrew pointed, it's also interesting, like, not to learn well. So, like people do.
Well, it's saying something about the nature of those neurons, or
Yeah,
the nature of your network. So.
Yeah, also the nature of people, because we also have these gaps, right, in knowledge. So it's good. It could be a whole new area for creativity. Okay, I just want to play it just to show how it sounds. It sounds terrible. It goes. Where it goes?
Yes.
So network generated. Here, right?
I think the master, I turned down the master.
Main mix, playback, okay. And it comes here, right?
Yes.
So it's in stereo 1B, which is this one, yeah? Or should be? Should I? No?
Don't press that. Press any of it.
Here. Yeah, HD taken to the HDMI. That's obvious reasons. Yeah, it's sine wave. Okay, I also wanted to show you square wave. Not that nice, but okay. I also want to play sine wave. It's even more interesting. And oh, no, please, not now.
Too much learning.
Yeah, something happened. Oh, I don't know. Yeah, I know, because I have opened this folder file and it cannot rewrite it. Yes. So here it is, and now just if I play this one. Yeah, questions, please.
the moment you're running 100 teaching cycles.
Yes.
So I didn't check your code, but I suppose you have a parameter for learning speed, or
Yes.
yes. So are you decreasing the speed while the epochs go further, or the teaching cycles go further?
It's not that easy. You cannot say that, like, if you do more epochs, then you do less speed. Basically, it works like that, but it's kind of finding right numbers.
But I was asking whether you take down the speed parameter.
Now it's 0.5 because I had that problem. I had this little bit fast speed, and then if it's too fast, yeah, as you know, it's kind of finding the bottom place on the curve idea. And if it's too fast, then it has kind of inertia. What is it in English? Impulse? No, yeah, it can roll up again somehow. So it's always a good idea to decrease speed. But if you make then too much learning epochs, I don't know, it's not about that mainly. It's kind of finding the numbers. In my experience so far, yeah, I haven't really experimented that much, but yeah, but basically it's right way to think like that, to make it slow and many epochs.
This is what I wanted, because that's my experience also.
Yeah.
You have to take down the speed while the process goes on. But obviously I don't want you to make it too good, because you will lose the nice character of it.
Yeah.
So, if I understand correctly, your training data is the input is a sine wave, and the output is the same.
Yeah, it's
sine
continuation of that sine wave. I took sine wave, I cut it into 1024 samples, and I'm just taking this chunk, cutting in the half, and taking as the input and output. So if it's the part of sine wave, like if we have sine wave, if I take this part, then this part is output. If I take this part, then this part is output, and so on.
Okay.
So, and the main thing is that it learns and it understands that, okay, if it's this kind of curve, probably the continuation is this curve.
So my question is basically, do you have a plan for more complex signals? How you're going to construct it?
So far, it's not a problem if the signal is periodic, because it can learn that. But so far, I haven't solved problem of changing signals. But I mean, Google's.
Have you considered doing this in spectral domain?
Yes, that's also idea for future. Spectral domain can also work. Now I'm just working on sample domain. I mean amplitude domain.
I was wondering what is kind of your motivation of doing this? That's kind of one question that I have.
Yeah.
The other question is like, what is, maybe this is linked to each other, like what is the reason for using such simple waveforms that you have?
Yeah. Okay, I will answer second question, because I just started to do it and it was kind of test for me. If I can generate simple waveforms, then I probably can evolve and go further and generate complex ones, and then changing sounds. So it's because it's just starting, and of course I want to go there. And the motivation, I already kind of said that his motivation is to build some kind of instrument, some software instrument which can listen to music. Like if I give it like all piano pieces from like history, and it just listens to it, it takes into input, learns, and then gives output. And then I don't have to compose.
The reason why I'm asking this is that like if you think about neural networks, they're very good in separating things as well.
Yes.
So it might be a good strategy to not go with what you consider to be the simplest possible problem, but start with something that is like complex and see how it fails, and then scale down from that and make it easier in that sense. Because then you also get an idea about like where the limitations are. I think at the moment you're more or less learning the linearity of the chunks that are in the sine wave.
Yeah.
And already like mixing, for example, the pulse and the sine in your training and test data might be worth to explore to see like what kind of irregularities limitations will come.
Yeah, the good points, and I will go there
And
for sure.
I think for neural networks, especially in this kind of small scale neural networks that you're doing here at the moment, because like this is not like deep learning means you have a lot of layers.
Yeah, of course.
Things, and you, with this, I think there's a big potential in this kind of failing, right? Like in the aesthetics of like, I'm sorry, but this is kind of my field.
Okay,
But it's in the aesthetics of failing of the network and seeing like what comes out. So it's,
Yeah, thank you for the point, and I'll think about it.
Yes. Thank you, Tornike.
Thank you.
Thank you.